The equation y equals 4x minus 3 represents a function. Remember, that means that if I have a value for x, my first set, then I can put it into that equation and it will give me a value for y, which is my second set. So it represents a function. The value of y depends on whatever the value of x is. For this reason, we call x the independent variable, because we can let it be whatever it wants. And we call y the dependent variable, because its value depends on whatever we let x be. Now, because the value of y in this function depends on the value of x, there's a special notation called function notation that's been developed to show that. We can call the variable y by another name, f of x. F and y refer to the same thing. They're two different names for the same thing. But this highlights the fact that the value of y actually depends on x. We read this f of x. It does not mean f times x. It means f depends on whatever x is. And so this equation y equals 4x minus 3 can be written with exactly the same meaning as f of x equals 4x minus 3. See, here is the function name, and here is the independent variable. The function itself is the same as the dependent variable. So whatever value the dependent variable has, the function has, because they're just two names for the same thing. So why do we use this notation? We use this notation to show the dependence of the function value on the value of our variable, our independent variable. And this is very convenient when we want to find the value of the function given the value of the variable. So if we say find the value of y when x equals 2, we know that that means in this equation we substitute a 2 in for x, and then we do the calculations to determine what y is. I can ask the same question much faster if I'm using function notation. I can simply say find f of 2. See, in this notation, whatever is in the parentheses following the function name, that is the variable. So if I say f of 2, that means I want my variable x to have the value 2. So it means the same thing as the statement above it. We're going to have f of 2 equals 4x minus 3, but instead of x, we want a 2. And so then we do the calculation, and we see that f of 2 is equal to 5. This process of substituting in the value of the variable to find the value of the function is called evaluating the function. And it's really the same idea as evaluating a formula. Here's a second example. Okay? We have a new function, g of x. I don't have to have an f here. It can be a g or whatever other name that I want for my function. So g depends on variable x. And here's how it depends on it. We're going to take x and square it, and then we're going to subtract 2 times x. That's going to give us our function value. So find g of 4. Well, the way we do that is we're going to take this 4 and substitute it into our function formula wherever we see an x. Okay? So there and there. So g of 4 is equal to 4 squared minus 2 times 4, which when we work that out is 16 minus 8, or 8. One more example. Let's find g of negative 1. So again, we'll be substituting negative 1 everywhere we see an x. And you have to be careful, because when we read this, it says x squared, which means whatever x is, we're squaring that. So we're going to square negative 1. Well, negative 1 squared is a positive 1. So when we're substituting negatives in, it can sometimes be an issue. We have to, or at any other time, we have to pay careful attention to exactly what's happening. The variable is being squared here, so we're squaring this value negative 1. Minus 2 times negative 1 is the same as plus 2. And so g of negative 1 is equal to 3. Now that we know what a function is, we want to focus on a specific kind of function for now, called a linear function. Recall that a linear equation is an equation in which the variable has exponent 1 or 0, nothing higher. A linear function is basically the same idea. It's a function that can be written in this form, f of x equals mx plus b, where m and b are real numbers. And the reason is because here, x has exponent 1, and here we just have a constant term. And so these are the only two kinds of terms we can have in a linear function. Notice the similarity between this expression and slope-intercept form, y equals mx plus b. And that's not an accident. Okay, any linear equation in two variables can be put into slope-intercept form. And once it is, then we can express it in this function notation like so, as a linear function. So to recall the two examples we've looked at, we see that f of x is a linear function because it fits the format, mx plus b. M is 4, b is a negative 3. G of x is not a linear function because it doesn't fit the form. It has an x squared term. And that violates the rule of being linear. Linear means x has to have exponent of 1, or else there has to be constant. So the x squared term means that g of x is not a linear function. The nice thing about linear functions is that their graphs are straight lines. So if we were to plot this function, f of x equals 4x minus 3, we get a straight line. And so then we can ask ourselves, looking at the graph, when is our function going to be equal to a particular value? In other words, for what x value can I get a particular y value? Well, for example, let's say we want to know when f of x is going to be equal to 9. To find that on the graph, we can first input our function into the first y, and in the second y, we can input the second value that we want. We want f of x, which is 4x minus 3, to be equal to 9. And so we graph the two, and that straight line is the line y equals 9. To find where this happens, we simply look at the intersection point. Here in the Calculate menu, we press the second button and then the Trace button to get the Calculate menu. And we find number 5 is the intersect So we're going to push the intersect. It asks us for the first curve. And see the cursor there that's blinking tells us that's the curve we're on. If we press the left and right arrows, we can go left and right along that line. If you press the up and down arrows, it's going to switch you back and forth between the two lines. So what you want to do is press your left or right arrows to get over to about where the intersection point is and hit enter. It'll ask you for a second curve. See, now if we hit left or right, we're on the other curve. So just hit enter again. It'll say a guess for what we're looking at for. This is not the answer. We have to hit enter one more time. And when we do, now see it says intersection. And it gives us x equals 3, y equals 9. Telling us that this point here has an x value of 3 and a y value of 9. And that tells us that our function has a value of 9 when the variable x has a value of 3. We can also do this algebraically. F of x equals 4x minus 3. When is f of x equal to 9? This is the question that we just answered using the graph. Let's see if we can do it algebraically. Well, I've highlighted the 9 in red to show that we're talking about a function value rather than a variable value. What this means is we can substitute this 9 into the equation right here for f of x. So we get 9 is equal to 4x minus 3. Now we just have to solve this equation. The way we always do, we isolate our variable term, and then we divide out the coefficient. We find x equals 3, which is the exact same thing the calculator just told us. Let's look at one more example. When is f of x equal to 0? You could do this on your calculator by putting in 4x minus 3 in the first y equals and 0 into the second y equals and finding the intersection. Or to do it algebraically, we substitute 0 in for f of x in the function equation. 0 equals 4x minus 3. Now again, we solve. We get 3 equals 4x, and dividing by 4, we get x equals 3/4.